Okay, so this is our problem, and let's go ahead and do it. So, William, why don't you go ahead and take the lead with me? So, what should I put here for the budget?
So for the budget equation, I got 261 equals 9x plus 8y.
Yeah, so the price of tacos is 9, and we're gonna let tacos be X. And the price of tequila, right? You said not 9x plus 8y, right?
Yeah, I
But
realized I messed that up.
yeah, no, but so you can see your mistake, right? So
Yes.
it's 3. So for the tequila, could you spend your money on tequila and tacos? So it's the price change doesn't factor in right now. And then for the tangency, we have our marginal rate of substitution is equal to the price ratio. And because this is Cobb-Douglas, we know that the marginal rate of substitution takes on this special form. So what did you get there?
I got MRS equals 36x divided by 64y.
Yeah, and in general, that's okay. But just to be clear, so here the alpha is 36 over 100, right? So that'd be 0.36. The reason why I said it would be fine is that since it's a fraction, right? And it'll be 36 divided by 100. And then the what did you get for the beta, the B value? That is
64.
Yeah, but it would be 0.64.
Right.
If you remember, beta is 1 minus alpha. So, but see, since you have 36 divided by 100 in the numerator and the denominator, the 100s will cancel out, right?
Right.
So it could be 36 over 64. It'd be algebraically the same, but I'm just gonna put it this way because technically speaking, the alpha is 0.36 and the beta is 0.64. You see what I did, right?
Yeah, I see it.
Yeah, and then for our px over py, we'd have what?
This is kind of the part where I was getting stuck on.
Well, so the px, we still know that, right? That's the price
Right.
of x is 9, and then divided by 3, right? So did everybody see what I did? Does anybody have any questions about that? Okay, so then William, you were asking about, well, so where do we go from here? Well, again, this is just 2 equations in 2 unknowns, and there's nothing special about this one, other than the fact that you have to decide, and again, normally what people do is you might recognize that these equations, the first one is what we call a general linear equation. And that's fine. I mean, there's nothing wrong with that, but it's not in a handy form for you to be able to begin solving. And likewise, the tangency is not in a form that we would readily work with, right? In order to use it to solve these types of problems. That's what makes this a little bit more challenging, but just a little bit, than a simple supply and demand system, because the way that we'd written those equations before in supply and demand, you have price is equal to this for demand and price is equal to that for supply. And you could just set them equal to each other, assuming the prices are constant, and you can just match up the sides of the equation. But here, you have to do a little bit of work first. And so, you have to kind of pick like, well, am I going to solve for X or I'm going to solve for Y first? And it doesn't, really matter which one you do. But what I normally do is I'll take the tangency condition and work with it first. And then I'll put it in the form of Y is equal to some function of X. You see what I'm talking about, William?
Yeah, I get it.
Yeah. So if you're going to do that, then we'll go ahead and work on it. We got to figure out, in the case of the tangency condition, if we move things around, what is that function? So is there anybody who has a question on how to deal with that, or do you need more help, William, or are you okay?
I think I'm okay for now.
Okay. So I'll give you all just another minute.
So what I got to is I just made 9/3 equal to 0.36 y over 0.64 x, and then I haven't done the math for it yet, but I'm just gonna basically move the y over and kind of just do the algebra for it.
Yeah. And that's what you should do. But these become sort of like a pattern. So I'm gonna walk through the algebra with you really quickly. So what I'm going to do is multiply both sides by 0.64x, and then I'll get the x over onto the right hand side. And then the 9/3 we know is just going to be 3, right? So that's kind of an intermediate step. Does that make sense, William?
Yeah.
And then I'll go ahead and I'll divide both sides by 0.36, and I'll get y is equal to 0.64x. And I'm just going to move things around a little bit, not because it's super important, but just so you can see how I did everything. And then I would get out my calculator and go ahead and reduce it. So, or, simplify the expression. So now I'll have y, and I have to get out my calculator. So 3 times 0.64 is 1.92. And then if I divide that by 0.36, I get 5.33 x. Okay, so does that make sense, William? Are you?
Yeah, that makes sense.
Okay, so now that I have this y, right, then the next step will be for me to take this y and substitute it into from the tangency condition into the budget. And when I do that, I'll just end up with one equation in X, right? So So now I'll have 261 is equal to 9x plus 3 times the value of y in terms of x from the tangency equation. So that's the 5.33x. So now I have just one equation in x, and then I can solve for x.
Professor, are we
Yeah.
looking for a y for this equation? Do we want to find out the amount at Tequila?
Well, so just so you know, right, for all of these simultaneous equations, you're going to solve for x and y. Okay, so we haven't quite finished this yet, but once we get our value for x, then we can substitute it back in to the other equation and find the value for y. So we could have set it up so that we find y first, but just kind of anticipating. Yeah, just kind of anticipating that we're going to, as we work through these problems, need both the value for x and the value for y. It doesn't really matter. It's not gonna like save us a bunch of time or something like that. So anyway, yeah.
Yeah, that sounds good.
Okay. So I'll let you all then, and so we would normally put a little, when we found the value for x we're looking for, put a little star by it, and that means that you know, this is our special value for x that we're looking for. And yeah, economists normally use that for like an equilibrium value. So you guys have seen me use P star and Q star. So this is an equilibrium value of the amount of x that the consumer is going to purchase. So do you want to finish it off, William?
Yeah.
So do you see what I did, William? What's your final value for x?
I got 10.44.
Okay. Do you agree, Scott?
Yes, I do. 10.44.
Okay, yeah. Now, I'll show you all. Then immediately from there, we can find our y star, which is the amount of tequila that we're looking for. And so we know from now that we have x, and we have this equation down here from the tangency condition, it should give us our y right away. So it's just going to be the 5.333 times 10.44. And that's the value I get. Do you all agree? Anybody have any questions? And that's the Ignithium answer. So any final questions on this particular problem? Okay. So from that, we got the answers to questions 11 and 12 on the homework. So let's go ahead and work on the next one, which is question 13. And you'll see that it's closely related. It's not the exact same question, but so this says before the price change, right? So I'll let you all work on this one, and then we'll come back in a few minutes. So just to show you really quick that in terms of working through these problems, right? So we get here to numbers 11 and 12 and 13, and we solve the tequila one. And then question 12 says, What's the utility maximizing quantity of tacos? And we get that. And then there's just a little bit of change in the language, right? So 13 says, how many tacos? Well, in the optimal consumption bundle, right? So this is just so to reinforce that you understand that when you solve the utility maximization problem, you're actually finding the components in the consumption bundle, that's the optimal consumption bundle. So the value is the same. And then question 14 says, how many tacos? And that's again to get you to realize that by doing this, that's what you're coming up with, is you're coming up with a prediction of how much the consumer will actually purchase. So it also has the same answer. It's only when we get down here to question 15 where it asks after the price change, then we have to solve the problem all over again using the new prices, meaning the new price of tacos, in this case 8, and the old price of tequila, because the price of tequila didn't change. So let me put that one up. So this is the new problem when we get down to 15. And the technique is the same, but obviously because the numbers are a little different, we'll get different answers. Okay. So you want to go ahead and go work on that one, Brian and Alex? We'll give you a few minutes. Okay, Brian, you see how this one's different?
Yeah, you just basically swap the price for tacos for that new price.
Yeah.
Yeah.
Okay, and what about you, Alex? Are you okay?
Yep, I got it.
Okay. But yeah, so these are the right answers for the optimal amount of tacos and tequila. And yeah, just, you know, by way of noting, only the amount of tacos changed from the previous problem. Now, I do want to show you one other thing before we call it a day. And so let's go ahead and come back and take a look at these problems. And so you with me, Brian? I'll just chat with you for a minute.
Yeah, I'm here.
Yeah, so there's your answer. And so now we get down to 16, and we start to have to estimate the effect of the price change on the purchase of tacos. And it's saying the total effect, and they're talking about the total change. And so you notice we had a price decrease. You have to really be careful and thoughtful when you compute these changes. Remember, anytime that you are going to compute a change, that the way that the change is computed is like this. So, okay. So the change in this case, the purchase of tacos, right? And the notation that I've been using is just dx, right? And so when you compute a change, then you need the amount after, so X after minus X before the price change. And the reason why I'm being careful about this is that sometimes there'll be a price increase, sometimes there'll be a price decrease. And we already know from the law of demand, right, that if it's a price decrease, then the consumer is going to purchase more. And if it's a price increase, they'll purchase less. So depending upon which of these is bigger, the X after or the X before, dx could be either positive or negative. And in the types of problems that we're solving here at the end of this chapter, the sign, whether it's negative, a decrease, or positive, an increase, is important for being able to interpret what happens when there's a price change. So in this case, remember the after, right, Brian, you had 11.75 minus the 10.44 from before, right?
Yeah.
And do you have your calculator? You can give me the exact value.
Yeah, I got 1.31.
Okay, that, and it's a positive, right?
Yeah, it's positive.
So and then I'll go ahead and paste the answer here. So, okay, so that's right. Good job. And then I'm gonna stop sharing, and then we'll take a look at how we're doing. So we're on number 16, and then number 17 is asking about how much utility, right, before the price change. So this is a pretty simple problem, because remember, we were already calculating utility levels up here in earlier problems, and how much utility, like question number 8, right? And how much utility in question number 9. So now that we have the optimal consumption bundle, the quantities, so in the case of tequila, we said it was 55.675, and before the price change, we said the professor was consuming a 10.44 in terms of the quantity of tacos. So we just substitute those values into the utility function, and we'll end up getting a number like we did before. And then here for 18, so we have the same sort of question, but it's after the price change. So we're going to use the quantities after the price change to compute utility there. So then we're all the way down to questions 19 and 20. And questions 19 and 20 require a different sort of technique than the one that we've been using up to this point in time. So that sort of technique is something that is explained in the videos that are online, and we're going to talk about in class. But now you have everything except for questions 19 and 20 that you can solve. Okay. Does anybody have any questions for me? Okay, I'm gonna stop sharing then, and I'll be back in then just about 5 minutes.